Hey, it's Dan here. Today we want to talk about possible rational roots using the rational root theorem. So we're talking about having an equation like this, f of x equals 2x squared plus 5x minus 12. And sometimes you'll be given the directions to find the possible rational roots. So when you have a polynomial equation, you know the possibilities for having different kinds of answers is somewhat endless. I mean, you could have rational answers, which would be answers that could be written as fractions. You might have some imaginary roots or imaginary answers to the problem as well. But what the rational root theorem does is show you the possible rational roots. So it's not going to give you the possible imaginary roots, but it will give you the possible roots that could be written as fractions. And so a long time ago, this was super important, especially when we didn't have graphing calculators and that sort of thing. We could find the rational roots, and then by doing a little bit of algebra, we were able to find all of the roots. So it's still kind of helpful to understand the rational root theorem. So let's jump into it. The rational root theorem says that if you find the factors of the constant term out here and write those down, and then find the factors of the leading coefficient here and write those down, when you form fractions with these over these, those are the possible rational roots. So let's do it. Let me show you. So when I'm thinking of the factors of 12, this constant term out here, I think of 1 and 12. I think of 2 and 6. I think of 3 and 4. Those are the factors of 12. And so I've written those down. Then when I think of the factors of 2, which is the leading coefficient here, I think of 1 and 2. And so now what I'm going to do is take each one of these numbers and form fractions with these on the bottom. So that would be 1 over 1 and then 1 over 2. So 1 over 1 and then 1 over 2. So I've used this 1 on top and then both of these on the bottom to get this. And you're going to make each one of these plus or minus. So it might be positive 1 over 1, or it might be negative 1 over 1. We're not sure which one it's going to be, so that's the reason we put plus or minus. Now I'm going to do the same thing with this 2. So I'm going to do 2 over 1 and I'm going to do 2 over 2. And I'm going to do plus or minus on those as well. And then do the same thing with the other. So I'm going to have 3 over 1, 3 over 2, and plus or minus on each one of those. So I'm using these. So you're going to do that for all of these. So 4 over 1, 4 over 2. So I'm using 4 over 1 and 4 over 2 like this. And then 6 over 1 and 6 over 2. And then last but not least, 12 over 1 and 12 over 2. So these are the possible rational roots or rational zeros of this equation. These are going to be the possible x-intercepts on the actual graph. If we were to graph this, those would be the x-intercepts. These would be the things, the possible rational answers where this problem is equal to 0 as well. Now we can eliminate some things. So like notice that 2 over 2 is really the same thing as 1 over 1. So I can mark through that. I don't really need that. Notice that 4 over 2 is really 2. So I could mark through that if I reduce. Same thing here. 6 over 2 is really just 3. So I can mark through those. And 12 over 2 is 6. So I can mark through those. So that limits the possibilities quite a bit. Now the old way that we would do this is we would take each one of these and use synthetic division until we found a remainder of 0. When you take these roots and you divide, when you get 0 as a remainder, then you know that particular number is a possible rational root. So you'd try positive 1, and then you'd try negative 1, then you'd try positive 1/2, and then try negative 1/2. It's a tedious method. Now today, because of the graphing calculator, once we get these possible rational roots, we've satisfied maybe our teacher wanting to see if we could use the rational root theorem, but what we would do is use our graphing calculator and graph it and then eyeball it and see which ones were going to be the answers. Now, I took the time to go ahead and factor this earlier, so I cheated a little bit. Some polynomials won't factor. This one will, though. So I have 2x and x to get 2x squared, notice. And then I need to multiply to get negative 12 and add to get 5. So I think it's going to come out to be positive 4 and negative 3. Double check me on that. So this times this is 2x squared. This times this is negative 12. This is 8x. And that's negative 3x. So that does add together to be 5. So that is actually going to be the factored form of this. And what that's going to mean is that, notice, negative 4 is one that actually works. So it's negative 4 from here. And then notice if you were to solve 2x minus 3 equals 0, you get 3/2. So the other answer is going to be positive 3/2. So you can see that negative 4 from here and 3/2 from there, those are in the list. So your possible rational roots, it doesn't mean every single one of these is going to be a root, but it does mean that if you have a rational root, it's going to be in this list of numbers here. That's what the rational root theorem does. All right, have a good one.